All right, I'm getting multiple thumbs up. So I'm going to go ahead and get started. But before I get started, welcome everybody to the first talk of the Science Perl track. This is the new this year for TPRC 2024. I want to particularly thank Will Braswell and Brett Estrade for helping coordinate the Science Perl track. So I guess with that said, Will, Brett, anything else? Just let her rip.
Thank you very much, Dr. Russell, for being our very first speaker of the new Science Perl track. Let's give it.
All right. Let's not set the expectations too high. All right.
I'm excited.
All right. Before I get started, after I made these slides, which deals a lot with the subject of knowledge graphs, I saw this posted. So like literally just like last night or the night before, I saw something about this. Is this a graph? And after you learn about graphs and the power of graphs, you start to see them everywhere. In fact, after a while, the skill is really to know when not to use them. Like this is just not well-connected data. There's really no point in forcing that particular model on things. But it turns out that graphs are a very universal data structure, and they are very helpful in many, many cases. And that's kind of what this talk is about at a very, very, very high level. Let me get the slides up. And so I guess let me introduce myself. I'm Adam Russell. The name of this talk is Structure-Based Structuring of Unstructured Data. I don't know why I gave myself a tongue twister of a title. But the subtitle is maybe a little bit more revealing: Automated Generation of Knowledge Graphs with LLMs. So we'll kind of go see what that means, hopefully in the next 50 minutes. But let's maybe give some background. I don't expect everyone to necessarily know what a knowledge graph is or sort of the background. So maybe we can just kind of start from a common sort of point of understanding. In fact, sort of funny enough, I made these slides, quite a while ago, but I didn't know there'd be so much talk about, the history of the Perl conference going back 25 years. And in fact, this is a slide from, I got it from the Internet Archive of March 2000, and it talks about YAPC 19100, which was referred to earlier. And this is a very Web 1.0 site, meaning that as far as I can tell, there is no dynamic content. It's entirely static. You click any one of these links, you're just going to get another set of images in HTML. I don't even think there's any JavaScript here. In fact, this is probably from the era where putting JavaScript on a page was considered like just crazy. Why would you do that? And now it's a whole like front-end multi-billion-dollar industry. There's a banner ad for, and you don't have to check. I checked already. Nerdgear.com is no longer in business. I don't know when they went out of business, but they're not around. But anyway, the point is, this is Web 1.0, entirely static, right? Let's talk about where we are now. And even though this screenshot of Perl.org is from almost 20 years ago, you can start to see how it's a link to the present. There's a link here to use.perl. If anyone remembers use.perl.org, it was a user forum created by Chris Nandor, Pudge, who I don't think is here today, but shout out to him. It was a really cool site for a long time. Along with Perl Monks, was a great place to communicate with other Perl developers, and that's kind of the point behind Web 2.0 is this rise of interactivity, the rise of dynamic contact, the initial, this is sort of like, with use.perl.org, you're starting to see like the initial seeds of the idea of like social media, right? You're connecting with other people, you're creating your networks of people who, you want to follow what they're writing, right? There's also some discussion here. There's a link to application programming. Web application programming is what that's about, right? And CGI, mod Perl. So this is the seeds of Web 2.0, and we're still in the Web 2.0 phase, right? Like a lot of this has evolved, of course, right? Over the past 20 years, there's nothing here to do with mobile devices. There's nothing here to do with the sort of the social media as contemporarily conceived, right? So that was Web 2.0. So what's Web 3.0? And that's really getting to where we want to be in this talk, right? So Web 3.0 was originally conceived by Tim Berners-Lee as the Semantic Web, right? Now I know I have to kind of say that some people, especially like in the, thank you very much, in the blockchain crypto communities, have tried to kind of describe their vision of what a Web 3.0 is. And so that's my reference to maybe something else. Later on in the talk, I think that it's possible to merge these ideas, but we'll get to that later. But let's imagine, like, what would a Web 3.0 version of Perl.org look like? Here is the current web page, right? Or at least it was current maybe like last week. Much more modern design, links to information to where you can download the latest release, which is 5.40, and links to documentation. I don't need to describe the website to everyone here in this room, but what does it mean, right? Let's ask ourselves the all-important question: so what, right? Now, if you're a human and you're going to Perl.org and you have a vision for the information you want to find, well, then it's there for you, right? You have a link to the documentation. You have a link to, say, a download. You have a link to a GitHub repo. The information's there as you as a human user. But what else is possible with this? What does it mean, right? How might you reason about that information? And let's take that word reason in the sense of like logic and artificial intelligence. How can you automate understanding information about Perl.org, right? And how can you get it into such a system, right? Now, I'm kind of I'm kind of calling out the considerations from 20 plus years ago with the original conception of the semantic web, right? Now, I think that in 2024, a lot of people will be like, OpenAI will suck it in, kind of memorize a bunch of things, and that information will be available through, say, ChatGPT in this kind of funny, lossy, compressed, hallucinatory kind of way. But maybe for a lot of people, that's good enough. But let's worry about that later. How can we understand, how can we apply natural language understanding, computable understanding to information on the web? And how can we join that meaning, the semantics of that information, along with the display, right? So it's 2024, we have this beautiful web page. How can we also, alongside the formatting of that information, also provide a model for understanding that information? Well, the answer is RDF and related technologies, right? And so these technologies we're talking maybe 25 plus years for some of them now, right? Especially RDF. And so this is how we might represent the meaning of information on the web. And this is the initial conception of the semantic web. Just real quick, if you're unfamiliar with it, and I'll give some code examples, but just to kind of set some definitions. RDF is the Resource Description Framework. It is a modeling language for stating the meaning of things, of semantic relationships and data. RDFS and OWL have similar purposes, which is for defining, for you as the programmer, for you the ontologist, to define what you mean by things, right? The classes of objects, the subclasses, the relationships, these custom, intuitive, human, logical properties and relationships. That's what RDFS and OWL are for. And they're largely for allowing this sort of automated reasoning and inference. If I were to define a relationship and set the domain to be, say, musicians, and the range to be people that own a musical instrument, right? Then if I, Adam, am assigned this property of owns musical instrument, then you can make the inference that I'm a musician, which I am not, but it is a nice example. It allows for that sort of human level intuitive reasoning, right? And we as humans make this sort of logical inference all the time, right? If you see me walking down the street with a trombone, you're gonna assume I'm a musician. Now, I might just be a lunatic with a trombone, but that's less likely.
Same thing.
Same thing. The anti-trombone contingent is spoken out. So what does this actually look like? So here is an example of RDF. Now, RDF comes in multiple formats. This is what's called turtle format, which is maybe arguably a little bit more readable. Here we define with the at prefix term, we're defining vocabularies that we are reusing. And this is very much just a snippet, right? This is just a couple of things. And so here we're describing the site itself, right? So Perl.org is an RDF type. The shorthand for RDF type is A. It is a website, right? And that definition of a website is coming from schema.org. It has a title, right? And so there's the Dublin core vocabulary, which is DC terms, right? So you have a title, a description. There is the friend of a friend schema, which allows us to say this is a home page, right? And that has parts, the sections of the web page, right? And then we can start to say information about those sections, right? So the downloads is we can say that it's a type of software source code, right? It is linking to source code with a software version, right? So we're able to make these statements about what this all means, and how might we have done this without this? Well, we would have an ad hoc, maybe web scraper, and we would understand what we were scraping, and we would kind of hard code or very manually sort of say, okay, I know the download link is going to go to, say, source code, right? And then we can start building these mappings. But if we define this ahead of time, we don't have to do it, right? Now, this is a graph, right? This is the graphical representation of what we just saw, right? So for purpose of explanation, rather than showing you even some nice readable turtle, maybe this is a little bit better, right? And so this is the RDF graph, the semantic knowledge graph of the parts of Perl.org, right? And this is an example I made up using Perl.org because this is the Perl conference. But we're going to actually, for the purposes of the work I'm describing, the purposes in the Science Perl Journal paper talk is related to, I'm going to talk about a rather different data set. But it's very powerful, right? But like I said, manually, you're manually writing this, right? And of course, we're all programmers. We can imagine how we can automate at least some of this. But it's still, I as, say, the developer of a site, I have to apply my own efforts into presenting this information in this way. And so that is great, but when you say, okay, now do this for everything, let's build out the semantic web, maybe it hasn't been the great success that was envisioned 25 years ago. Now, we can argue why that is, right? Maybe because no one wants to give away valuable information for free. Data's the new oil, right? That was a big phrase for a while. I don't want to be overly cynical. I think that sometimes the effort just doesn't have the reward, right? Like, what if you are, Best Buy, why would you put your entire catalog in RDF format at best, you're going to help a handful of people that are interested in such things. At worst, you're just making it easier for your competitors. What problem are you really solving for yourself? Maybe if you're an executive at, I'm just making up, Best Buy, you don't see the value in it, right? However, if you are a researcher in the bioinformatics field, you do see the value in this, right? And so there have been some large areas of success of large shared ontologies. Bio-ontologies are maybe the biggest ones I can think of off the top of my head. Also, the Wikipedia project in their DBpedia has a very large, semantic database that you can query. So there are silos of success, but not broad adaption, right? So how can we more broadly apply, create these semantic knowledge graphs for purposes where maybe the manual effort is not worth it, right? The trade-off of having some ontologists and programmers go through your data and creating these representations is possibly, not worth the effort. But if you were to automate it, maybe it'd still be worth doing. And so when we think of automation in 2024, we think of artificial intelligence, and we think of large language models in particular, especially when we're thinking about text data. So how might we automate the construction of semantic knowledge graphs by first defining ontologies, right? So, we still have human beings involved that are defining with their human intuition and their human understanding of the domain. Human domain understanding is irreplaceable, right? Define those ontologies, and then with the support of large language models, build out the graphs as needed, right? Now, I had started off this talk with like some sort of a common reference point of Perl.org website. For the purposes of this work, I used a financial prospectus style document because I think it's a really good example of unstructured and semi-structured text, and it's also a problem domain, the area of finance, where there's a lot of natural language, unstructured text, right? Not just in the trading world or like prospectuses, but just disclosures, it's a highly regulated environment. There's a lot of reporting that has to be filed, and there's certainly templates and sections that have to be completed in those reports, but there's not necessarily any impetus to have them in a structured format that's easily digestible by computers. So, just to give a high-level overview, we're going to take one single financial document. In this case, I'm going to call it a prospectus-style document. A prospectus is generally going to be like dozens and dozens of pages. This is just a couple of pages. It's more like a financial fact sheet for a certain ETF, exchange-traded fund. In this case, called OBTC. OBTC is the Osprey Bitcoin Trust, I believe. And we're going to ingest that document. Oh, first off, it's a PDF. And so there's the Poplar utility, which is used for extracting the text. So we're dealing with just the raw text sources. So there's some formatting issues, which we kind of deal with a little bit. But then from there, it is kind of really contemporary LLM style application development, right? You can view this as really a retrieval augmented generation, or RAG, problem. The text from that document is broken up into document chunks. We create embeddings. I'm going to go through all of this, right? But just to kind of give an overview, the document is chunked. We create embeddings. We define queries based on the properties in our ontology. And then we generate prompts, so some automated prompt engineering. We use our RAG process to get the relevant chunks, ask our questions, and get the answer, and finish out our graph. So what does this look like? So this is one page of this document. And can I zoom in a little bit? Whoops. I don't know. You get the idea. You can see that there's just a bunch of text. I would say this is maybe more semi-structured. You have a table here. You have some sections. But you also have some fine print. Do I have page 2 in this? No. Oops. Hold on a second. Lost my scaling here. So this is page 1. Page 2, which I don't have in the slides, but page 2 is actually a lot more of this sort of fine print, right? So it's a good test case. Now, like I said, we're going to apply our human intuition. We're going to apply our human understanding of this domain to create a basic ontology or schema here. Here we're using RDFS, and that is extremely hard to read. Even zooming is just a sea of white text on a black background. What was I thinking? I was thinking that this was very hard to fit into LaTeX, which I used to make the slides in Beamer. So I thought a slideshow. Anyway, why don't I just jump to the next slide, which is a graph of this thing, right? And so here we define things like sponsored by or has ticker symbol, right? These are the properties. And so we're using RDFS schema. I'm defining new properties about this document. I'm saying, okay, there is a sponsored by property. There is a has minimum initial investment property, right? And so if you're familiar with, if you're less familiar with ontologies, but more familiar with object-oriented programming, you understand this sort of has a kind of relationship, right? And the concepts are exactly the same as they are in the ontology world, right? So we have has minimum initial investment, has additional investment minimum, right? So this is all information coming from the document that's just kind of there, it's just kind of written in English. Sorry, I just gotta resume things. Maybe there's an easier way to do this, but okay. So we define our schema, right? So I'm going through the process right now. Thank you. I'm going through the process right now. So how does this look like? Step 1, define our schema, right? Step 2, pretend like we didn't define our schema. So what that means is, if you're working on a team, you might have a dedicated ontologist who has a deeper sense of domain knowledge than other people on the team. You might also be reusing industry standard ontologies, right? So if there's no need to reinvent the wheel. If you have a nice ontology for the sort of information that you're after, please don't reinvent the wheel, right? Reuse what's out there. And in which case, you're going to be getting all these custom properties that you don't really necessarily know about. And you don't want to have to target your code to understand them, line by line. What you can instead do is, in this case, query out the properties. And this is an example of Perl and Sparkle, right? So let me actually take a quick tangent. So this is using a framework, a module called Attean, A-T-T-E-A-N. I think it's pronounced Attean. If anyone knows better, let me know. There's a couple of other modules I use here, AI embedding and Open AI API. Both very handy modules, and I'll show them in use later, but I kind of wanted to, since this is the Perl conference, kind of talk about the stack a little bit, right? So this is Attean. This is a very simple Sparkle query just saying, give me all the properties in this graph, right? And the graph itself is kept in the triple store, which is saved in a variable here called store. I'm not going to go line by line through this code, but just keep in mind what this does is it's querying out all those properties, and now we're going to get an iterator over those properties, and then we can start creating prompts, right? So for each one of those properties, construct a natural language question and use that question with a RAG Q&A exchange with an LLM. And then populate the graph with the answer. Done. Easy. No, maybe not. But let's talk about RAG a little bit. This is, using the power of Perl, a RAG, a retrieval augmented generation retrieval in, I don't know, a couple dozen lines, right? It is good enough for these purposes. When I get to the end of the talk, I'll talk about maybe how this sort of thing can be improved. But what this is doing is it's creating the chunks, right? So I've defined a subroutine which which chunks the text, right? So we can have a separate hour-long talk about chunking strategies, but for now, I'm just creating fixed size chunks of text, putting them together, and then every time we have, say, a fresh chunk of text, I'm calling the OpenAI API and then creating a text embedding. This is what you would call a bog standard RAG, right? I'm using ADA 002 embeddings from OpenAI. And so I create this pair, right, of chunks and embeddings. And then the reason we're creating embeddings, if you're not familiar with text embeddings, they're floating point vectors representing the text and the meaning of the text based on a model's understanding of it. In this case, we're using the OpenAI GPT-4's understanding of text without any fine-tuning or anything like that. And we're creating embeddings. Once we create the embeddings, we're able to do cosine similarity comparisons. That's what this embedding model compare method is doing. It's comparing pairwise the prompt, which has been generated from the property. It's comparing that prompt against the chunks of text, and the chunk of text which is most similar according to cosine similarity is selected and then moved on to the next process. Now, typically in RAG, you would do a top K retrieval, right? Top 5 is common, right? This is picking the top one, right? A little bit of cheating, right? This is the document is not super complex, so I kept the code a little bit simple just for the purposes of explanation. So how do we create these prompts from a property? Well, we have some options, right? Simple. I mean, this is actually maybe classic NLP right here. You know, what's option one? You know, a templated construction of text, right? That's what Eliza did in 1967 or whatever, right? Then we have use a more grammar-based method, right? I don't know who in this room might be aware of some things like grammars, say prologue, DCGs, right? But any sort of you could parse the property and then generate text based on that. Very classic, very powerful NLP technique. Or we could use an intermediate LLM to generate, and this is an emerging area. Meaning that the papers on using LLMs to generate input for LLMs is things that I read a paper on last week. New things getting dumped into the archive every day. Maybe a good example that is relevant to this is how if you're familiar with RAG, you know there's a suite of a framework for generating metrics, including a relevancy metric on RAG results. The relevancy metric in Ragus is generated exactly this way. It takes the answer and then retroactively builds a question, right? So this idea of generating questions given a certain context is a new area, an emerging area. How you might fine tune those questions based on your domain is another area of, again, very current, very emerging things. So the future is still being written. I will say that for the purposes of simplicity, we took we, the Royal Academic we, took the first option, right? But exploring these other two are, that's where the future work lies. That's where this can be scaled out and hardened and improved. So at the end of the day, what is the result? Well, the result is this nice RDF graph, right? It's sponsored by Osprey Funds. It has this QSIP. This is a run of the code written for this paper. Now, is this perfect? Well, arguably no, right? For example, like in true ontologies, you don't want to have dollar signs and commas and money. You, in fact, probably want to have a very precise definition of for currency and the denominated the denomination. Is it dollars? Is it euros? So this is a little bit simplified, but we're allowed to, and it works pretty well. This is pretty good, right? If a graphic, and again, this is a graphical representation of just one document. You can imagine the universe of these documents. Imagine every, say, ETF on the American exchanges, right, could have this sort of graph. And it's nice, right? It works pretty well, but it's naive, right? Where's the naivete come in, right? And some of these are simplifications, just to have like tight code that prototypes and explains a process. Some of it is just because the state of the world hasn't caught up, right? So, for example, chunking optimization. It's an area of active work, right? I took a very naive approach. I think I said, okay, just kind of eyeballing the document. If I were to say create set chunk sizes of 10 lines, that should mostly work, and it did, right? But that was lucky of me, right? So how else might we have chunked the document? We might have had some sense of the structure of a document, identifying paragraphs, for example. We could also try to have sort of an intermediate understanding of the document and create chunks based on that. The sky's the limit. I mean, that's the potential for a whole nother talk, right? Is how you could optimize the chunking strategy for not just all documents, but just maybe a narrow class of documents. The RAG improvements in tuning, right? So right now, not super complex document, RAG just kind of worked, right? Our basic RAG worked. But how might we create an internal feedback loop, right? How might we start chaining these actions? For example, maybe we have a heuristic based on metrics. We use something like I mentioned, Ragus, the Ragus framework, right? We use those sort of metrics to have some understanding of how good the answer is. It could be that we didn't luck out. The LLM didn't understand this. It didn't return a right answer, or it was looking at the wrong chunk. How might we say try again in an automated way? Totally open, right? This is the sort of AI work that's occupying a lot of people's time right now. The prompt automation, I described 3 strategies, talked about the one that I used, but really exploring those strategies for prompt automation is, again, possibly very deep work, right? And how you address that can remove the work from the human domain expert that you have helping you create your ontologies, right? The more you can automate that person's job, the more you're leveraging AI, right? And helping sort of expand their power of, their domain knowledge. And how might we QA this thing, right? So imagine at the end of the day, we create a beautiful SKG of every ETF on the American stock exchanges. How could we test that, right? And and there, I mean, people are already doing this sort of thing. For example, you could, just look for regressions. The set value for something, has that value changed as you updated your graph? Has the new information you've brought into your graph, does it look like other changes you've made, or is it just this crazy peak in like new elements that don't really make any sense? Again, very new, very, very new stuff. That is kind of where I wanted to leave off and ask if you had questions. I kind of ended this with, it's all really new and this is very emerging, and that's because it is. I think this is interesting. I think that this is really I was telling Brett this before the talk started. There's a certain hype train around large language models, right? And like you can just picture it as this like bullet train, this fast locomotive just heading down the tracks, fueled on hype, right? And it's kind of running out of gas. I think that a lot of organizations are understanding the limitations, the natural limitations, and the natural risks around the use of large language models. And so having large language models do what they're very good at, which is parsing text, question answering, and then coupling that with classic AI techniques, creating these ensembles where you can use the LLM for what it's good at, and then creating the ability to have more trustworthy, more powerful, deterministic, more easily explainable answers. I think that's, well, I'll give my opinion. I think that that's definitely a very strong path forward, right? But that's very much my opinion, and I know that there's people staking many billions of dollars in the other direction. But catch me in the hallway. Maybe we can talk about these sorts of things. Maybe I'm wrong. Maybe you have a different opinion, or maybe you agree. Any questions? Yes, sir.
Can you give us your most far out, futuristic, sci-fi idea of where this might be useful in the future? Like,
Yeah, sure.
Robots or flying cars or what have you, the Jetsons.
So for the audience, the question is, what is my most, and I'll kind of rephrase it a little bit, and you tell me if I'm rephrasing it correctly. What is my most speculative science fiction proposal for how this might be used in the future? Could it lead to a Jetsons-like life? And so I would back up maybe away from the Jetsons. I would actually maybe go back to 1999 and how Tim Berners-Lee and other people that were very excited about the semantic web envisioned how it would be used, right? This great altruistic understanding of all the world's information in this easily computable format. Just incredible, just automation and understanding. Imagine the perfect search engine. You go in and you ask who won the Switzerland-Germany soccer match, and it understands, oh, you're asking this on June 24th, 2024. You must be talking about the game, I guess it was the day before yesterday, and bam, here you go. I'm not going to try it live. But I think that if you were to do that with even like ChatGPT, it would maybe give you, just maybe make up an answer from like 2022 or whenever it was last changed, right? I think that, so the most speculative thing I can say is that we would have this utopian vision of free and easily computable, easily accessible information all out there, right? If I were, say, Bill Gates or another pick your tech billionaire, if you made the investment, you could take what I've talked about, and scale it out. Like I said, invest in those projects to, really drill down on chunking, really drill down on prompt generation. Really drill down on all these things and then apply this to everything that's out there, Build your own, massive understanding of the world. But that actually kind of gets away from, on my earlier slides, I talked about, the crypto community's vision of Web 3.0, which is very loosely defined, I would say, which is around this idea of this vague sort of hand-waving thing of more artificial intelligence, greater decentralization, right? And we've seen just universally that there's been pushes away from centralization, right? Like, the original sort of vision was, with like business cards and you stating your identity and how those can be shared universally. Now there's a central website for that called LinkedIn, right? Most people do their social media on like Facebook or a couple of other sites, right? There's any great centralized idea, decentralized idea, historically, or at least in recent history, has been compressed down into these silos for usually business reasons, right? Like, the push for Git, this great decentralized source control system, was so that, you could work on the Linux kernel while, taking a train through the Alps or something, right? And now everyone uses it in the most centralized possible way using GitHub, right? Now, of course, there's the decentralized ability is still there, and sure, a great number of people use it. But maybe just to kind of continue answering this the long-winded question is like, maybe, the most speculative thing is maybe we finally do realize, greater areas of decentralization, right? And then maybe in that case, the original vision of the semantic web, right, and the current crypto AI wave my hands because I don't really get it thing, maybe those do kind of come together, right? Maybe the use of blockchain as an inherent decentralized mechanism can help fuel this somehow. Wave my hands, I don't know, but certainly the AI piece is here, right? So that was a very long answer. Hopefully an enjoyable one. Yes.
I don't remember the exact wording, but for the intermediate prompt generation, this emerging idea, what do you think are the opportunities with like models prompting?
So the question is, what do I think the opportunities are with improving prompt generation, specifically for this process or just in general?
When you mentioned the intermediate,
Mm-hmm. Oh, okay. Sure. If I understand the question, which again, to repeat it, is how might the using an intermediate LLM to improve prompting, how might that work, or how might it improve things? So I'm going to have to refer you to a paper which I think devised a system called Codec LM, in which they fine-tune an intermediate LLM to create better prompts. So imagine before we call out to, OpenAI, we have our own LLM, and maybe it's not even, maybe it's some, it's Llama, it's something open source on our, and it's fine-trained against all of our data. And let's pretend we're, some sort of brokerage or something, right? In that case, we have a very well fine-tuned, domain-specific LLM, which will generate questions better than the broader ChatGPT one, right? I mentioned a paper called Codec LM, which kind of does that, right? But that's basically the idea, that you would be able to generate, but through fine tuning and customization of your own LLM, you would generate the best possible questions for your domain. Any other questions? Yes. Oh, last question, the sign says.
Would it be correct to say that one of the applications for this that it seems pretty immediately implied would be something like massively reducing the effort required to build these tightly scoped interrogatory systems, like, for example, in a video game where you're talking to non-player characters, they normally have a canon set of questions you ask them, and they give you a set of responses. Generating those, from say just the
Yeah, let me repeat that and maybe try to sort of reword that and compress it down a little bit. So the idea, there's a couple examples in that question, which was, for example, you suppose you're a video game studio and you have a book of lore and you want to maybe automate the interactions between player characters and non-player characters. Could this be used for that sort of system? And then I think you gave another example of, what was the second example?
Say for example, a tutorial system.
Oh,
for a piece of machinery.
sure. Or a tutorial on the latest John Deere tractor or whatever it is, a piece of machinery. Could you then also maybe automate that information in the same way, right? A tutorial, an expert system, and maybe a different example or a different domain of a lore book and video games. So the answer is yes, right? And that kind of ties to the last question of where if you have very precise lore, then yeah, you'll probably want to fine tune an LLM for generating your questions in that example. And also, probably for sure, if you're an equipment manufacturer, I'll just make up John Deere, then yeah, of course, yeah, absolutely. And could you then create, based on your ontology, I'll use maybe the John Deere example, can you create an ontology for like understanding how to fix, a part on that machine based on human written instructions? And the answer is yes. And I think they're actually already doing it. I think that, but not this way, right? So a few years back, I was at a knowledge graph conference, and there was someone maybe it wasn't John Deere, maybe it was Caterpillar, but they were talking about the use of knowledge graphs in troubleshooting equipment failures and coming up with solutions, and they had a very, very compelling presentation. So. Yeah, the answer is absolutely yes. And this sort of thing would improve that sort of system, which to an extent already exists.
Especially the manufacturers, because they want something that will never hallucinate and then a very tight scope of questions.
Absolutely. And that's exactly where I think the power in this is, right? Is that you have a completely grounded knowledge graph, which you can query. And you can query it using, there's lang chain libraries for generating Sparkle queries, right? So you can have natural language queries and with an understanding of your knowledge graph ontologies, generate queries. And they work okay. I mean, again, this is all still emerging, So yeah, the answer is yes. And it's, for a relatively, I would say, dry kind of academic talk at a conference, this is, I think, pretty exciting. It keeps me writing code, right? If you want to talk more about this sort of thing, beyond just now and in the hallways later, stay in touch. I'm on all the socials. And in fact, there's a nice Discord server, which I started a few years back and actually is kind of alive. So actually, I don't want to jinx it. I actually see some decent activity. So join there. I'm on LinkedIn, our centralized place for professional social networking. I'm on Mastodon. I don't know. I mean, I'm out there. So stay in touch. And you saw my email at the beginning of the slide. So I saw the last question thing. So I guess we're done here. All right. Thank you very much for coming.